working of PN junction diode, as full wave rectifier. Working of PN junction diode as full wave rectifier. For that we have to draw the diagram. We have to draw the diagram of full wave rectifier. First of all, we can draw input AC source. This will be input AC source, and these two terminals are terminals of primary coil. Terminals P2 are the terminals of primary coil, and we can draw secondary coil. We can draw secondary coil or two terminals of secondary coil, and these are two terminals of secondary coil. S1 and S2 are the two terminals, and also we can denote this symbol, that is, two straight line indicates that mutual induction occurs between primary coil and secondary coil. And this is what T means, obviously step down transformer. And here what we can write, step down transformer. And right hand side we can draw alternating voltage. At the input we have to apply alternating voltage. Alternating voltage is Vi, and time is plotted along horizontal axis, and this is input AC source, and this is input AC source. This is input alternating current source or alternating voltage source. And here we can draw positive half cycle and negative half cycle. And this is what alternating voltage. This is alternating voltage. And we can denote positive half cycle by this way. This is positive half cycle, and negative half cycle, and this is negative half cycle. Again we can denote this as positive half cycle. And this is negative half cycle. Negative half cycle. Now to the two terminals of secondary coil, and two PN junction diodes are connected in this way. This is the first PN junction diode. This is the first PN junction diode, which is D1 is the first PN junction diode. Which has P side. This is P side of the PN junction diode and N side of the PN junction diode. To the terminal S2 there will be another PN junction diode. This is P side and N side, and this diode is D2. Load resistance RL is connected in this way. This is load resistance RL to get finite voltage. And here we have the output terminals. This is the circuit diagram of full wave rectifier, and output is measured across the load resistance RL. Output is measured across the load resistance RL. So here at the output across the load resistance RL, we shall get this type of output voltage. Output voltage is denoted by VO. Output voltage is denoted by VO. And time is plotted along x-axis. In this case, we shall get this type of voltage versus time axis. Voltage versus time axis. Positive half cycle will remain positive half cycle. These are the positive half cycle, but negative half cycle will be converted into positive half cycle. Will be converted into positive half cycle. And here at the output we get positive voltage always. We get positive voltage always. And this is what direct alternating voltage at the output. This is known as direct output voltage. Direct output voltage, which is measured across the load resistance RL. And here what we can write, alternating input voltage. Alternating input voltage. Alternating input voltage. Alternating input voltage. So this is the circuit diagram of full wave rectifier, and in which there are two p-n junction diodes D1 and D2. They are connected to the two terminals S1 S2 of secondary coils. And here this coil is primary coil of step down transformer. This is the primary coil. This is the primary coil, and this is secondary coil. This is what known as secondary coil. Secondary coil. And below this again we can draw input and output waveform. Below this we can draw input and output waveform. Below this we can draw input and output waveform. This is input waveform. Here what we can write, input waveform. This is input waveform. Input voltage is Vi. Origin, O is the origin, and time axis. Time is plotted along horizontal axis. And in this case, voltage changes in this way. It remains positive during that time. Then it becomes negative again. It becomes positive. then negative, and then we get positive half cycle, then negative half cycle, negative half cycle. Now we can denote this as positive half cycle and also negative half cycle. This is negative half cycle. Again we can draw positive half cycle, then negative half cycle. This is positive half cycle, then negative half cycle. Below this we have to draw output waveform. Below this we have to draw output waveform. Output waveform. Below this we have to draw output waveform. Along a vertical axis, output voltage across RL is plotted, and along x-axis time t is plotted. Time t is plotted, and this voltage is output voltage across the load resistance. O is the origin. Time is plotted along x-axis. Time is plotted along x-axis. Now we can draw the scale of time. Within this scale, positive half cycle will be confined, and within this scale of time or range of time, negative half cycle will be confined. Then again we can draw this type of imaginary straight lines to keep the voltage in a certain range of time. This is positive half cycle, then negative half cycle, positive half cycle, then negative half cycle, positive half cycle, then negative half cycle. In this way you can draw output waveform. Positive half cycle remains positive half cycle, but negative half cycle will have 180 degree phase change and it will become positive half cycle at the output. And this is positive half cycle, and this will be again positive half cycle which is obtained from negative half cycle. In this way we can denote negative half cycle which will be converted into positive half cycle. All the half cycles are positive at the output. So this is input and output waveform. In this case, obviously this negative half cycle is converted into positive half cycle. Here this negative half cycle is converted into positive half cycle. But positive half cycle remains positive half cycle at the input, at the output. Now we can explain in what way positive half cycle remains positive half cycle, and in what way negative half cycle will be converted into positive half cycle. At a certain moment, we can say that at a certain moment P1 has the negative terminal, the negative voltage, and by induction S1 will have positive voltage, and P2 of primary coil will have the negative potential by induction. Similarly, the terminal P2 will have positive terminal, and S2 will have negative terminal by induction. In the same diagram, you can denote negative and positive terminal of primary coil. Here what we can write, during the positive half cycle, during the positive half cycle, during the positive half cycle of the input AC source, of the input AC source or AC source at the input, input AC source comma P1, the terminal P1 of primary coil, the terminal P1 of what type of coil? Primary coil, secondary coil of step down transformer, primary
coil.
Primary coil of what type of transformer? Step down transformer. It should be step down transformer. That's why number of turns in primary coil is greater than the number of turns in secondary coil. Step down transformer is T, is negative and the other terminal, which one is the other terminal? The other terminal P2 becomes positive. Other terminal P2 becomes positive. P2 becomes positive. In this case, during the positive half cycle of input AC source, the terminal P1 of step down transformer is negative, but the other terminal P2 becomes positive. P2 becomes positive. Below this, write on account of self induction or mutual induction. On account of which induction? On account of self induction or mutual induction. S1 becomes positive on account of mutual induction. On account of mutual induction in the transformer, comma, the terminal S1 becomes positive, and the terminal S2 of which coil? And the terminal S2 of the secondary coil will have the what type of potential? Becomes negative. And see here, this positive terminal, that is positive S1 terminal. S1 has the positive potential and this S1 is positive potential, which is connected to P side. That's why this diode is forward biased. This diode is forward biased. This diode is forward biased. Forward biased. So that as which side? The P side. As the P side of the PN junction diode D1. There are two PN junction diodes, D1 and D2 are the two PN junction diodes. PN junction diode D1, as the P side of PN junction diode D1 is connected to positive S1 terminal, comma, the diode is forward biased. Diode is forward biased. Diode is forward biased. And what about the other diode? And the other PN junction diode, which one is the other PN junction diode? D2 will be reverse biased as its P side or P region, P side is connected to negative terminal. Which terminal? S2. In this case, obviously the PN junction diode D1 is connected to positive S1 terminal, and the diode, that's why the diode is forward biased, and the diode D2 will be reverse biased as its P side is connected to negative terminal. Hence, so here what we can write, as P side is connected to positive S1 terminal, so this diode is forward biased. The diode D1 is forward biased, and as P side of the diode D2 is connected to negative S2 terminal, that's why this diode is reverse biased during positive half cycle. During positive half cycle means what? We have, this is positive half cycle, then negative half cycle. So we are considering that this positive half cycle is connected to this terminal, and due to this positive half cycle, P1 has the negative potential, and P2, the terminal P2, has the positive potential. And in this case, if we denote the forward current, this is the forward current I is the forward current. In this case, this diode offers low resistance, and forward current will pass through this diode, and the forward current will be coming and will be flowing in this direction. But here the reverse current I prime is the reverse current. Here I prime is the reverse current. And I is the forward current. And the diode D2 offers what type of resistance against reverse current? Offers high resistance or very high resistance against the reverse current. That's why this reverse current I prime will be 0. It will not pass through the diode D2. The diode D2 blocks the reverse current. And here obviously which current will be flowing? I will be flowing. I prime will not flow, and a cycle is completed. That's why a current I or forward current I will be flowing across the load resistance RL due to the conduction of diode D1. Due to the conduction of diode D1. Due to the conduction of diode D1. Hence, what we can say, hence the forward current. Here, which one is the forward current? Please respond. I na I prime?
I.
The forward current I flows through. Forward current I flows through the diode D1. Flows through the diode D1 as it is forward biased. It is forward biased and it offers low resistance. It offers low resistance against the forward current I. Against the forward current I. Forward current I. Below this, but the reverse current, which one is the reverse current? I prime, will be blocked by which diode? Will be blocked by the reverse biased PN junction diode D2. PN junction diode D2. As this diode D2 offers very high resistance. Very high resistance. Hence, positive voltage will be obtained across the resistance RL. Therefore, what type of voltage? The positive voltage is obtained. Positive voltage is obtained across which element at the output? Across the load resistance RL. Load resistance RL at the inputs, at the output terminal. At the output terminal. At the output terminals. That means this is the output terminals. That means output is measured across the load resistance RL. Output is measured across the load resistance RL. And if we draw output voltage, and this is the input positive half cycle. This is the positive half cycle which is applied at the input positive half cycle. At the input, and at the output or across the load resistance RL, this will be again positive half cycle. That means due to positive half cycle at the input, what is obtained? Positive half cycle at the output. And this is also positive half cycle. Positive half cycle at the output, terminals or at the output. And this positive half cycle at the output terminals is obtained due to the conduction of current by the diode D1, not due to the diode D2. The positive voltage is obtained across the load resistance RL at the output terminals due to the conduction of which diode? Due to the conduction of diode D2. Here what we can write? Due to the conduction of current by which diode? Conduction of current by the diode D1, by the diode D1. Now we can draw the diagram again. This was the details during positive half cycle. Now we can consider negative half cycle. What happens during negative half cycle? During negative half cycle, of input AC source, that means if we draw input waveform, this type of input waveform during negative half cycle, means this is the negative half cycle or negative voltage, this is the negative voltage, and this is the negative half cycle which is applied across the two terminals P1 and P2. Negative half cycle. Negative half cycle, and in that case terminal P1 and P2 will have the reverse potential. P1 will become positive and P2 will become negative. Here you have to draw the diagram again. So if you have time, then you can explain the negative half cycle also. P1 will have positive potential and P2 will get negative potential, and S1 will get negative potential and S2 will become positive due to mutual induction. And at the input we shall get what type of voltage? At the output, and if we erase this part, in this case obviously the diode D1, this diode D1 will be reverse biased. Diode D1 will be reverse biased, and diode D2 will be forward biased. Because diode D2 is forward biased because its P region is connected to positive S2 terminal. That's why the diode D2 is forward biased. but diode D1 will be reverse biased because its P region is connected to negative S1 terminal. Now through the diode D1, I prime or reverse current is flowing. This is reverse current. This is reverse current which will be flowing through the diode D1. But we can denote the forward current which will be passing through or flowing through the diode D2. I is the forward current. Under bracket of I, what we can write? Forward current. So in this case, forward current will pass through which diode? Diode D2. In this case, current I will be flowing. Here I is equal to I. But on the other side of diode D1, what will be the value of I prime? I prime will be 0. Here I prime will be 0 reverse current and forward current is I. This is forward current I. I will be flowing in this way. So at the output, RL is the load resistance at the output terminals, and if we draw voltage, in that case what positive, there should be positive voltage at the output. There should be positive voltage at the output. And this is positive half cycle, and this will be the positive half cycle at the output. This is the positive half cycle at the output. So what we can say, that is this negative half cycle is converted into this positive half cycle at the output or across the load resistance RL. Due to the conduction of current by which diode? Due to the conduction of current of the diode D2. During negative half cycle of input AC source, comma, the PN junction diode, which diode? D1 is reverse biased, and the other PN junction diode will be what? Other PN junction diode D2, other PN junction diode D2 will be reverse biased. Hence, what type of
forward bias হবে তো?
Oh, forward bias.
D2 তো স্যার ওই forward biased হবে।
Thank you. Will be reverse biased, and D2 will be, the PN junction that D2 will be forward biased. Forward biased. Hence, positive half cycle will be obtained across the load resistance RL, at the output due to the conduction of current by which diode? Due to the conduction of current by which diode? D1 or D2? Conduction of current
D2.
Due to the conduction of current by the diode D2, by the PN junction diode or by the diode D2. Hence what we can say, negative half cycle will be converted into positive half cycle. Therefore, what we can say in this case, negative half cycle at the input terminals, is converted into what type of cycle or what type of voltage? Into positive half cycle during negative half cycle of input. Negative half cycle of input.